Hi, this is Lee. It's July 21st, 2019, and I'm going to demonstrate all of the TRILLSAT radio communication systems. And this is using version 1.2 of the software, which I haven't released yet, which includes just mainly bug fixes. And what I'm going to do is I'm going to show you, now that's inverted, TRILLSAT-1, and it's going to communicate with TRILLSAT-G. And TRILLSAT-G is just a limited version of the radio systems in TRILLSAT-1 because I can't build another TRILLSAT-1. It's too difficult. So I just built the radio systems, and it runs the same software as TRILLSAT-1 for demonstration. Okay, and this is TRILLSAT-G. Slightly different hardware, same software, and inside this ARC here is TRILLSAT-1. I'm going to go ahead and open this. Okay, and I lower the ARC door, and this is mainly a storage container, but it acts as a machine in a frame mode, I call it. And then there are these braces. I'm going to pull off a brace. This has different purposes. It can mount on the side like that, and then the TRILLSAT-1 can hang in between them, or it can act as a lower brace for the frame, which is a larger piece of equipment. I'm going to put that aside. And that's TRILLSAT-1 inverted. It's sitting on its solar panel, and this is nighttime right now. And I call that inverted TRILLSAT standard orientation, or ITSO mode. And I've got the planetary assembly disassembled right now. And inside, this is the planetary mass, which in the future I plan to put a lower radio inside it. I'm going to set this off to the side. And there's the radio box. Everything's turned off at this point. And over there is the power regulation box. And there's the gondola in the center. Now, let me just show you what's in the radio box before I turn it on. See if I can get in here. Okay, I just pulled off the panel. And there you see the Baofeng UV-5RA radio disassembled with a 50 ohm dummy load on there. It's a 4-watt dummy load, but I'm going to run the radio at 1 watt using that dummy load. And then underneath the radio, that copper, which goes underneath the radio, is the packet radio interface, which uses a Saiba CM119 chipset-based USB audio card. And then right there is a Raspberry Pi 0W. Right there is an ESP8266. And, oh, sorry, right there. And, sorry, that's a piezo speaker. And then right here is circuit board A. So I'm going to go ahead and close that up. And you see it's grounded. That's what that wire is there. Okay, it's off. And turning it on requires me to sort of jump start it. Normally in the daytime, sunlight would activate the solar panel, and then the solar panel would turn on the ESP8266, and then I would be able to start up the rest of the system. I'm going to have to do that manually because it's nighttime and it's on its solar panel. So what I've got is little alligator clips connected to the positive and negative terminals on the gondola here, and I'm going to plug it into 5-volt USB, and I'll just go ahead and do that right now. Now the ESP8266 has power, so I'm going to bring the TRILLSAT-G and set it up here, because what I'm going to do is I'm going to power everything via battery power. After I jump start this, I'm going to switch it to battery power. I'm going to remove the cable, and I'm going to switch this to a USB battery bank to simulate a similar system. TRILLSAT-G, by the way, has a Raspberry Pi 2 with a TP-Link USB Wi-Fi adapter just for testing purposes. It does not have the Raspberry Pi 0W, and it has a different sound card. It has a UCA202. It's a Behringer audio device which uses a TI chipset. And then it has a similar Baofeng UV-5RA radio and a similar dummy load. This one's vertically polarized, the other one's horizontally polarized, but I'll be testing them so close to this antenna that it won't be a problem. And let's see, and there's a little ESP8266 there as well. And that's because in both these systems, the Raspberry Pi and the ESP8266 act as master CPUs. They can be used independently of one another. In the actual TRILLSAT, there's a couple of other microcontrollers for the motor control and for power regulation. And there's one in here and then in here. But those aren't used for the radio communication. So I'm only going to demonstrate the radio communication systems. And over here, I have a Raspberry Pi 3 that's going to act as a base station. And the Raspberry Pi 3 is right here. And as you see, I've got some terminals open on it. I haven't connected to anything yet. And what I'm going to do is use these terminals to connect into the Raspberry Pis via the Wi-Fi adapters on both cards, just so you can see the output and what's happening. The ESP8266 has the ability to tell the Raspberry Pi to shut down its Wi-Fi card, and then it could just use the ESP8266 Wi-Fi card as well. And of course, everything can also communicate over the ham radio as well, bypassing both of the Wi-Fi systems. So what I'm going to do here is I'm going to get everything on battery power, and then I also want to show you, these are the clients that I'm going to also use to communicate with it. These are smartphones. This is Nexus 4 and this is a Nokia 6.1, and they're both running Xabber 1.0.74. And you see got them drawn here. That's TRILLSAT-1. TRILLSAT-G is going to be the Nokia. Because I'm going to show a few different things. I'm going to show that these devices, or at least TRILLSAT-1, actually both devices, TRILLSAT-1 and TRILLSAT-G, they can access a router, which they're doing. Once I boot them up, they'll automatically access this router because I can use this for testing. I can use it for updating things over the internet, patching things, but that's just for testing purposes. The really neat thing is that they can act as their own access points independently of any router or internet, and they'll also do that automatically if they lose connection to that router. But I can also force them to switch, so I'll show that. Then I'll show how I can control the frequency of the radio and the power for the radio, and that's that radio here. The power control subsystem is not added to TRILLSAT-G because it's just the radio system. And I'll show the multi-user PBBS, show sending mail, I'll show chatting with the station operator over a phone like this. I'll show texting. Now when I say texting, I mean XMPP to the ESP8266 here, which will use the Raspberry Pi to transmit packet radio. The packet radio will go over the air here to the other system, and will go to its Raspberry Pi, to its ESP8266, and then end up at this phone here. And it will do that completely automatically over ham radio. It's just a matter of sending the command, and then it will initiate the communication. And there's no wireless infrastructure other than the systems inside these two units. And ideally, this would be another TRILLSAT-1, or it could even be a packet station. It doesn't have to be another TRILLSAT. It could just be a standard, base station like this with a packet radio system or TNC on it. And then I'm going to show the APRS beaconing feature, and that it will actually change to the APRS frequency and send out a beacon, and change back to the packet frequency all on a single VFO, which is unusual. And then I'll have it. I'll show you how the Pi Wi-Fi isn't needed. It can operate it can shut shut those down, and the ESP8266 will take over. So that's pretty much what I'm going to demonstrate. Okay, so on TRILLSAT-1, this phone has connected. The phone that I'm holding is another Nexus 4. Ideally, I wanted to use two Nexus 4s, but it has a bad digitizer, and so I can't touch certain areas of the screen, and it senses ghost touches. So I had to use this for recording the video and use more reliable phones for showing the actual communication. So it's going to be a little hard to hold this and show this. And also the focal range. I can set the focus when it's not recording video, but as soon as I record video, I cannot further adjust the focus. So, and the autofocus will frequently stop working. So I'm going to go ahead and send a hi. Okay, so well, it didn't say anything because hi is a command for the Raspberry Pi, which is shut down. So I'm going to send an ESP hi. Okay. Let me see if I can focus it. Hi, this is the ESP responding. Okay, and this one hasn't connected because I have not yet turned on the TRILLSAT-G, so I'm going to go ahead and do that. I'm going to plug in the battery bank. It should be in focus now. Now, if you see, it's booted up. There's the light on the Raspberry Pi 2, and it's connected to the 802.11n router. Now it says TRILLSAT-G just started. I'm going to send an ESP hi to it. Okay, hi, this is the ESP responding. Okay, so I've got to get this thing on battery power. Before I do that, I'm going to go ahead and turn on the Pi. I'm going to do a Pi on. And while that's happening, I'm going to come over here, and the Pi should already be on TRILLSAT-G. So I'm going to SSH into it. Okay, TRILLSAT-G I got into, and I'll go ahead and SSH in here as well. Okay, and let's see if I can get into TRILLSAT-1 now. This is a Raspberry Pi 0W. And I'm going to go ahead and stop the bot that's going to run, because I don't want it to run until I manually start it, just for testing. Okay, so the last thing I'm going to do is get another terminal open into it here. Okay, so TRILLSAT-1, I've got two terminals open into it over the Wi-Fi connection, and I'm still going to the router at this point. And over here I've got TRILLSAT-G I'm accessing. By the way, if you're wondering what this thing is, this is actually my game that runs on a AT-Tiny microcontroller, the same kind of microcontroller that's in, there's two of them in TRILLSAT. And I'm going to open this up just so you can see it in there. And it's an AT-Tiny 1634 with a LED and piezo speaker. And actually, there's a Morse keyer here, and I'm going to go ahead and play the game so you can see what it looks like. I just type north, and see that @ sign is already up north, so it's blocked. There's a wall there, but if I were to go east, and that would be an E, which is just a DIT, and I hit another DIT, and what I'm doing is I'm pushing this keyer here, DIT, and it's responding back. And it's a success east, and it moved the character, that at symbol, to the right. The Syntheo decoder that's inside this game is also inside TRILLSAT, but that's part of the haptic system. I don't use Morse over the airwaves at this point, just packet, 1200 baud packet. Okay, so let's see, the first thing, I still gotta get this thing on battery power. So what I'm gonna do here is run the bot manually. Going to the TRILLSAT directory. Okay. Okay, now it does some temperature calibration when it first boots up. And what it does is it launches Direwolf, the software modem, and it's set for 1200 baud. And then it creates an AX25 port via pseudo terminal, port 1. And so anyway, the bot is now running, and what happened over here, and it just sent some garbage that was last buffered, and then it says please set time. The time system is unusual. I have to explain this. It's because there's no real-time clock on the Pi, there's no real-time clock on the ESP8266, so I can go ahead and set the time when it loses a time server. Right now it sees the time server because it's going over the router, and I've got it configured to do so, so I don't really have to set the time. But when it loses the time server, I can run a command to set the time, and it will set it on both the Raspberry Pi and the ESP8266. And then I can pull the time later from the ESP8266 if the Pi ever goes down, so I don't have to continue to reset it. So there's at least one system that tracks the time, and I plan to add that to the ATtinies as well. So I'm going to type a hi command, make sure that the bot is responding, and it says unknown command. Let me try it one more time. There it goes. So the garbage that was in the buffer is clear at this point. And over here you can see that the bot is printing some output. It's saying that it received hi, and then it's producing the status, which is the presence, the XMPP presence, which is up here. Okay, so that bot is now running. There's a similar bot on TRILLSAT-G I'm going to run. Okay, the bot's starting up. Normally these bots run at boot automatically, and this one's a lot faster because there's less equipment in it. But again, it runs Direwolf, it creates the AX25 port, and that's running fully on battery power. So that one's already off the grid. I've got the radio turned off at this point just to save battery power until I'm going to test it. And then I can control the radio power here automatically. So now let me do that 5.2 on. That's interesting. As soon as I did that, the squelch, you can see this is the, I've never seen this before, this is the radio frequency interference, or the emissions that are being put out by probably that boost converter I just turned on. So it is adding some noise right now because the antenna here is so close. I'm going to move the antenna a few feet away before I test. Let me turn the squelch off on this. So the 5.2 boost converter is on, and you see that it says it's on. So at this point, I can unplug the USB power, and the Raspberry Pi and ESP8266 should remain running on the 5.2 boost converter. I'll do that now. Here it goes. Actually, I'm going to unplug it here. No, I changed my mind. Open it here. Okay. Let's see if it's still online. I'm going to send another hi to it. Okay, it's on. So I'm going to go ahead and pull these cables. Okay, now TRILLSAT-1 is on battery power at this point. The ESP8266 and Raspberry Pi and the boost converter are running on battery bank 2, and this, of course, is running on that bank right there. All right, now I'm going to hit S. Well, actually, yeah, I'm going to try series mode first before the boost converter. And here we go. Oh, there's some more interference. Okay, series command is on. That turned on. I put 2 battery banks in parallel to provide 7.2 volts so I can power that radio on. And added a little bit of interference here. I'm gonna have to squelch that again. And I've got an AFSK decoder here. So when I actually start sending packet, you'll be able to see the output from a separate system. All right, so at this point I can turn the radio on. I'm not going to do that yet. What I'm going to do, let's see, the auto access points. I'm not going to do that yet. Turn on these access points because I want you to see the output via the Wi-Fi cards in the Raspberry Pis. So what I'm going to do here is show you the radio frequency and power control. I'm going to type a radio on. Okay, and the radio just came on, and it's at 145.030, the 1 watt low power narrow band. And that's because I had preset it. But I can change the frequency. Now I can change the frequency by typing F and then the frequency in megahertz. So let's say I want to change it to 145.010. Now when I do that, it's going to, it's a clone mode radio, so I have to overwrite the flash, but I can overwrite just 16 bytes with that frequency, and then it will attempt to make the write. Then it will try to make a read to confirm that it's at 145.010 before showing it up in the status display. Now it's hard to see because I've got it vertical. I'm going to go ahead and turn this sideways. And this is Android 9, so I've got this icon I'm going to push. Okay, and then you can see the entire display if it's in focus. And it says 145.030. And I'll go ahead and do the same to this. And this is 145.030. Now this doesn't have as much on the status line because it's just the radio system. It doesn't include all the other subsystems. So here we go. I'm going to show you changing frequency. I'm going to go ahead and hit enter here. 145.010. Let's see what happens. Just hit it. Okay. It changed and rebooted. So the write was correct. Now it's going to try to perform a read. And it just did that and it rebooted again. And the read should be correct. And let's see if it said it was successful. It said setting and then it went to 145.010. So it just changed frequency on its own. And did you see how quick that was? Normally, if you're using Chirp or some software like that, it's a long process. It takes many seconds. But I got it to write that 16-byte chunk and even read it to confirm it in that short of a period of time. It's not always reliable, and there are timing issues. I had to quarantine the radio in many cases and shut it down. So there's a whole system behind that. So I'll go ahead and change it back to 145.030 because that's what I'm going to test with. And here we go. Just sent the command to switch. 145030, is it the write was successful? Now it's going to perform the read. 145030. This is a good day. $145,030. All right. So at this point, what I'm going to do is show the multi-user BBS because I've got the systems are both on battery power. I'm still SSHing into them. So what I'm going to do is turn on the AX25D daemon. So I'll go ahead and turn the daemon on this G device. So what I'll do is I'll run OTA, and that means on the air. And what it's going to do is launch the daemon. It says unknown command. Let me try it one more time. It's probably because some information is buffered. Okay, radio is now on the air, BBS enabled. And when I did that over here, it saw the command, and it should have launched the AX25 daemon in the background. AX25D daemon. So at this point, I can call it. Now, this is interesting. Right now, I'm going through the router, and I've got these Raspberry Pis that I'm communicating with over SSH. I'm not using these access points yet, but the AX25 software in Linux had to be configured in a particular way for testing, because normally you're not calling a system that's operated by your own call sign. So I had to use different SSIDs, and that's this number here at the end, the 3. So the system TRILLSAT-1, what I'm going to do is I'm using AX25 port 1 on both systems, and the reason I'm only using 1 is because there's only one TNC in essence running on the system. There's only one instance of Direwolf acting as a TNC, and but this one here, this SSID, what I'm going to do is I'm going to be call sign 1, which is my call. I'm going to have my call sign in place of that, and I'm going to call sign 3, which is going to be my call sign again, but SSID 3, and it's configured as via 1, which is going to be that same port 1, and then what it's going to do is launch the PBBS in mode 1. There are a couple of modes that the BBS can operate in. Mode 1, which is the normal BBS, and then there's mode 2. And these modes are modes I set using APRS in Python. They're not actually, it's easier to show you. Okay. Okay. And as you see here, at the end here, I say mode 1 and mode 2, and that's just an argument or a parameter. And the actual SSIDs are 3 and 4, but in this conf file, I'm able to specify that if it sees the SSID of 3, it sends a parameter of mode 1, and if it sees an SSID of 4, it sends a parameter of mode 2. And then in the Python TRILLSAT BBS.py file, which is the actual BBS software that launches, the X25D daemon will actually launch it, and it will launch multiple versions of it depending on how many callers there are. Then it will read that parameter and go into a certain mode. Now mode 1 is the BBS. Mode 2 is the texting mode, where it will do a simple handshake and then transfer a short text. And that's all handled in the program. So I'll go ahead and close out of that. So I went ahead and shut down the OTA mode. I'm going to go ahead and launch it again. Okay, on the air. So at this point, I'm going to go ahead and initiate a packet session from TRILLSAT-1 to TRILLSAT-G. Now this would be equivalent to having a base station like this, of course. I'm going to use the call command, port 1, my call sign, and then I'm going to do call sign 3 because it's listening on call sign 3 for that particular BBS. Okay, and once I hit this, this radio which is on, 145.030, will try to contact this radio, and I'm going to turn it on right now and adjust the volume. I know kind of where to adjust it from experimentation. Okay, that's at 145, it's kind of hard to see, 030. And they'll start a communication session between them. And this will be demonstrating the multi-user PBBS. So I just hope it works here. This is all on battery power. Okay, well, it took me a long time to figure out, and what was going on here is that the polarization actually does have an effect this short of a distance, and with those dummy loads, they have to be that close to get reliable communication between them. So I had to remove the UV-5RA transceiver and put it kind of close to the other transceiver. In actual use, there would of course be 2-meter antennas. It would be high in the air, and the wattage could be increased to up to 4 watts. So these things could be miles apart, but right now I've got these things for testing purposes attenuated. So, and they're down at 1 watt. These dummy loads, they with a high gain antenna at this 1 watt, I've done some tests, and after only about 200 to 300 meters, the signal drops to the noise floor. Okay, so we've got 5.1, 7.1, the 5 volt and 7.2 volt boost converters are on battery bank 1. That does reduce some of the interference, where putting the battery banks in series seems to increase it for some reason when the boost converter is activated. So I'm going to go ahead now and try to call the BBS. Okay, there it's just trying, and there it has contacted the BBS. And that's the menu. It says welcome to the PBBS. And as you see, that was a transmission that occurred, and the BBS is the one in the middle there. And that's the decoding of AFSK by a Gqrx. And right now, the radios aren't doing anything. It's in that quiet zone. AX25 has a lot of these quiet periods. So now I can go ahead and issue commands. So this is the BBS, and that's running on TRILLSAT-1 right now. Everything's on battery power. Everything's on battery power. I'm going to go ahead and hit I information. And at 1200 baud, the BBS is just giving some information that it's an experimental station. Python. The battery on this camera phone that I'm using is going to die soon, so I'm going to have to plug it in. So that's the information. Then I can hit question mark to bring the menu back. Okay, and again, these are the packet communications taking place, and there it's being decoded by a third-party system. I'm going to go ahead and let's see. Now here's where it gets interesting. First I'll do send message to the station operator, and this is a store and forward type of mail. So if I hit M, It says enter message and type /ex to send. So here I'm going to enter a message. Hello, this is a test. And then I'm going to do period. I'm going to do a /ex. And it says message has been sent. But if you notice over here on this phone, it says KD0YJM1 has left a message. Now remember, this is the phone that's connected to TRILLSAT-G. So TRILLSAT-G is the one that's right now we're calling into, that's hosting the BBS. We could also call into TRILLSAT-1 if we want. But it said there's a message. So that message now can be read by the station operator at any time by hitting R or hitting D to delete the messages. If the station operator is not around or the phone's not connected, they'll just start to accumulate on the system, and then it can be read later, like email. So I'm going to go ahead and type R. Okay, and there is the message. And this is coming from the phone that's connected to the ESP8266's XMPP server that I wrote on it, and then that's reading the files from the Raspberry Pi. I'm going to go ahead and hit D for delete. It says deleted all messages. Okay, I'm going to go ahead and plug this phone in because it's dying. Just a second. Okay, I've inserted a clip here. I recorded this several hours after the clip you just saw a few seconds ago, and that's because I forgot to mention that the station operator can send a command to send a message to various call signs, and those are stored on the BBS, and then when those users actually connect to the BBS, it will report if they have a message or not from the station operator. So it goes in reverse like that. I'm going to go ahead and do that, but first I'm going to show you. I'm going to, this time I'm putting the BBS on TRILLSAT-1, and I'm going to use TRILLSAT-G to connect to it. So for TRILLSAT-1, I'm going to put it in OTA mode. Okay, it's on the air, and then I'm going to connect to it. And this is going to be connecting via TRILLSAT. Call sign 3 is connecting to call sign 1. There it's connecting. Okay, it's connected. And what's happening here is this call sign 3 is connecting to the BBS and call sign 1 here. And the reason I'm showing you this is because now I'm going to go ahead and send a message. And the message is going to be sent to the call sign 3. Okay, so I'm saying M, the call sign 3, and then test message. And when I do that, it won't send anything over the radio at this point. It's just stored the mail on the server. But then a user that's actually connected to the BBS, when they log in or if they refresh the menus, such as I'm going to do a question mark to refresh the menu. Okay, there it says you have mail from KD0YJM1. Type R to read. I'll go ahead and do that. And there's the message. So it's just test message, and then it says test message. Okay, so that's the other way that messaging can occur. I'm going to go ahead and return you back to the other clip. Okay, so we're still connected, and as you see, the radios are quiet. That's what's nice about AX25 is it gives these quiet zones, and I actually took advantage of that when I created my APRS beaconing system. So let's see, what else can we do? We can do request live chat with the station operator. So let's try that. C. Okay. And it says chat with KD0YJM3 has been requested. Station operator has been paged. Let's see if the station operator has been paged. And sure enough, chat request. And then, of course, I just wanted to show you the bots that are running on these two systems. They're doing all the work behind the scenes here. And that's the AFSK being decoded. So, if the station operator, let's say, is in range of one of the TRILLSATs, gets this chat request, what happens here is you can also see that KD0YJM1 is connected. So there could be multiple users and they'll show up in the presence here. And of course OTA mode is turned on, that's why it's acting as a server. So I could go ahead and I think it's C, that means chat with, and then I'm going to type the call sign. Okay, for instance, multiple users could send chat requests, and then you could pick the person that you wanted to talk to as station operator. So I'm going to go ahead and do that. Chat mode has been enabled. And as soon as that happened, of course, there was a transmission that occurred. And these things are constantly communicating with each other. And what happened over here is it says station operator has enabled chat, entering chat mode. And I can say hello. This is a test, let's say this is a test 1. And then it starts the chat. And then over here it says, hello, this is a test 1. And then I say response test. And you can just keep typing back and forth, and then this just says station operator said response test. And then it can continue that way, and a person could chat back and forth. So what's happening is the station operator that has this phone can chat in real time with a person miles away on a packet station, and of course they're connected to TRILLSAT. And in this case it's just this one here, but I could easily do it off of that one as well. So to end the chat, type end chat. The station operator has control over the chat. Chat ended. And communication is taking place. And it says station operator has entered the chat, and it takes the person back to the menu. So that's the chat system. And the other thing is, let's see. So I showed the mail system, the chat system, the multi-user PBBS system. I showed the frequency and power control. I haven't gotten to this yet. Now the texting system. The texting system is completely independent. It does not require any kind of terminal like this to be operated through Wi-Fi. I'm going to leave the terminals up just so you can see what's going on here. But this is a little different. And first let me go ahead and disconnect from that BBS. I'm going to hit B for buy. Okay, it's cleared. And these things are disconnecting. There's the X25 protocol, there's the disconnection. And now it's going to go quiet. These radios go quiet. So let's see, what am I going to do this time? I could, let's see here. I'll go ahead and do it from TRILLSAT. No, I'm going to reverse it this time. I'm going to turn OTA off. Okay, so that BBS is off the air. This one is now off the air. I'm going to turn the BBS on, or yeah, the BBS on that one, OTA. Okay, now the BBS is on TRILLSAT-1. It's not on this one. So this time I'm gonna do something different. I'm going to tell TRILLSAT-G. I'm going to text the person that's on TRILLSAT-1. So let's look here. I'm going to be this person, call sign 3, on TRILLSAT-G this time. And this time I'm going to contact this call sign 2. And what this is going to do is it's going to initiate a handshake between the two systems using this particular mode. Let me just demonstrate. Okay, so I'm saying I'm going to send a text to that particular call sign, and the text is going to be test. This is a text. Now, when I hit this, this radio here will start to transmit the message. This AX25 daemon will see that a message is coming in for call sign 2. It will go into the texting receive mode. It will perform some handshaking, receive the text, and then it will send the text to this phone. So say there are two people, one person here, one person here. This person's going to text that person. So let's see what happens. Sending text. You should receive a confirmation response soon. Okay. And the handshaking now is going on. You see test. This is a text. Your text has been received. You see the what is your text? That's the handshaking that's going on. And of course nothing's happening here because there's no BBS. And look what happened here. It said text from KD0YJM3 test. This is a text. And then everything just goes quiet because that was just the simple communication. It made the connection, and it sent the text, and it disconnected. And of course, if this person wanted to respond, assuming that this person has their server running, so I'm going to type on OTA on this one as well. So now that one's on the air. So now both of these systems are on the air. I'm just going to send a response. Call sign 3. Oh, but I can't respond directly to call sign 3. Because even though call sign 3 sent me the text, the texting port is call sign 4. So that's a technicality right now that I'm working with. There's a few ways I can get around that, but for now I'm going to operate it with that in mind. Okay, I received your text, thanks. And let's see what happens. Okay, now this one is decided to send, and it sent it over to that one, and they're handshaking again, and they're disconnected. And let's see what happened. And there it is. Text from KD0YJM1, received your text, thanks. So that's the texting system, and there's no AC power, there's no cell tower, there's no wireless infrastructure. Technically, at this point, these phones are connected to a router, and I mentioned that. Now I'm going to show you how the texting works without a router involved. I had some SSH sessions going on here, kind of to show you what was happening on the server. I haven't really shown those much. I'm going to go ahead and switch over and get off of the access point, and I'll send a text afterwards. So in this case, I'm going to do a switchnet command. and that will force the ESP8266 to disconnect from the router and become its own access point. Okay, at this point, I will lose connection to it. If I type hi, for example, I will not get a hi back. And the reason is because I've lost connection to the access point. I'm going to go ahead and do it over here as well. And this is going to become its own access point. I'm going to go ahead and refocus. Okay, that took a while. For some reason, there's a slightly different versions of the OS which seem to do different things. This phone, for example, would not see the TRILLSAT-G access point for a while, and it finally showed up. This one saw it pretty quickly. I even oriented the antennas around in different ways. This is running Android 9 AOSP, the open source project, on the Nexus 4. And you see it's now connecting to TRILLSAT-1, no internet, and that's because there's no router involved. And it's running right on the access point in the ESP8266 in TRILLSAT-1. And over here, TRILLSAT-G, there's also no internet because it's running on the access point, and it's on that ESP8266 right there. And this is running Android 1, the latest build for the Nokia 6.1, so it's slightly different. Now I'm going to go over here and show you something. These terminals, they're still connected to the Wi-Fi cards on the Raspberry Pis, and I haven't disconnected that at this point. They're still going through the router, but these phones are no longer going through the router, so I'm going to go ahead and turn off the Wi-Fi card. There's a disable Pi Wi-Fi option here, so I'm going to go here. Looks like the screen is a little dark. I'm going to go ahead and brighten it. By the way, before I do that, I just want to show you that it is reconnecting to the bot that's running on the Raspberry Pi, but it's doing it through the access point on the ESP8266. I just said hi and it returned hi, and that's going through the ESP8266 to the Pi and not through the Pi Wi-Fi. Similarly over here, it says hello there. Okay, so now I'm going to run Pi Wi-Fi off. Okay, the Pi received the command to turn off the Wi-Fi card. So at this point, there's Pi Wi-Fi off, but I'm going through the Wi-Fi card. Let me try typing a command here. And look, I've lost connection to it. And over here, I still have connection to it. So anyway, it's now disabled over there. And I can go ahead and do another text, for example. How about another test? So I'm going to text that call sign another test. And there they are again. It's a little too bright. And then over here it says another test. So the text occurred without any Wi-Fi card on the Pi active. It was completely through the ESP8266 and through the amateur radio. So that demonstrates that. So I demonstrate the auto access points. Everything's been demonstrated so far except for APRS beaconing. Okay, the last thing I'm going to demonstrate is the APRS beaconing system. It's one of the most complicated systems on TRILLSAT, and it allows this single VFO radio to change frequencies in the middle of a packet session. Multiple people could be involved, and then send out a beacon on the APRS frequency. Currently in the North America, that's 144.390 megahertz. And then after it does that, it switches back, and then it resumes where it left off in the middle of that BBS session. So what I've done here is the Wi-Fi card has been turned back on TRILLSAT-1. I've made TRILLSAT-G off the air. So, and then I've reactivated, since the Wi-Fi card is reactivated, I've got these terminals activated. And what this time I'm going to use this terminal to contact TRILLSAT-1 with the BBS, and then I'm going to manually send out the APRS beacon. Normally they go out every 30 minutes, but I'm going to force it to go out, and it's a complex chain of events. You can't just stop an APRS, you can't just stop an AX25 transmission in the middle. If you pause it, things break, and things get queued up also that will go out on the wrong frequency. So I created something called the stupor process. It slows down the entire process, and it does that so it doesn't respond, and then it speeds it back up, kind of wakes it out of its stupor at the end. So what I did was I inserted some large timer values into AX25. I used the AXCTL command. Then I sent a notification to everyone connected to the BBS that a beacon's going to go out and not to use it. I tell the BBS itself to ignore requests. Then I wait a while in case any messages have to go out, anything is queued up that has to go out, anything to be received, because you want to clear out that queue. And the reason for that is when you inhibit the push to talk to prevent the transmitter from activating, and then you uninhibit it when the APRS beacon goes out, anything queued up can actually go out during that time. And that's kind of, Direwolf is smart in that it queues things up, but it's something that I kind of don't want. I'd rather have something lost than saved in this case. Ideally, I would send out a receive not ready frame, but I'm not able to do that. Maybe in the future I'll try doing that. It goes out, then it switches to the frequency. It has to confirm it's on the frequency, because if it's not on the APR, well, let's say that you're on the APRS frequency and then you switch back to your original frequency, but you're still on APRS frequency, it could actually start sending out AX25 communications related to that session on APRS, and that would not be a good thing, because APRS is just for APRS types of packets. So, and then when it's done, it awakens it out of the stupor, and then it sends out a notification that it's complete, and it takes about 90 seconds. And sometimes it doesn't work. Sometimes the radio hangs during programming, and I have to quarantine the radio and shut it down. There's a lot of strange things that occur. It was difficult to create. Okay, so what I'm going to do is I'm going to close that. I'm going to get this ready. I'm going to do a call. And this time I'm going to call call sign 1. Remember, before I called call sign 3. Okay, I'm going to initiate a call to the BBS, and this time it's the BBS on TRILLSAT-1. Okay, it's connected. That's the communications that were in progress. Okay, so at this point, I'm going to go ahead and initiate the APRS beacon. Okay, it's telling everyone a beacon's going to go out. I'm going to switch to 144. It should go quiet until that beacon goes out. In the meantime, let's see what's going on over here. Okay, there the capture card muted. Looks like it's changing frequencies. It's verifying. And that's the APRS beacon. And that's the beacon. Now I'm going to switch back over to 145.030. And there's the beacon, by the way. And there we go, I'm back. Thanks for waiting. Okay, now that was during a quiet time. I could actually start to queue up information in the BBS, have that beacon go out during that time, and it would try to quiet things down, then it'd mute everything and send out that beacon. So far it's worked. I'm not sure how reliable it's going to be with many users and a lot of information. But again, this is experimental. So I'm going to go ahead and say bye. And it's cleared. And by the way, this is what occurred on the phone. It said sending out beacon. Okay, so that pretty much covers the functions of the radio communication systems on TRILLSAT. Again, there's a haptic system, there's other microcontrollers that control all the robotics. And again, this is the inverted state of TRILLSAT. Normally, this is flipped upside down with the solar panel in the sky, with the motors going on. So this craft normally hangs like that. Well, but it's reversed. It kind of would hang up in a tree like that at an angle, and then the sun would be over here. This is all under battery power at this point. And there's a lot of different power systems that, there's switching it into parallel. There's switching the battery banks. There's the solar power itself. So I haven't tested all the options. This is just the rudimentary testing of the radio systems. And I'm going to create a couple more videos for the motor systems and the solar panel, the power regulation systems. So those two videos I still have to make in the future, but I wanted to get this video out. Thanks a lot.